Hey everyone, welcome to the fourth episode of Distributed Systems 101 series. So, in this episode, we will be talking about conflict resolution in multi-leader replication scheme. In the previous episode, we discussed about multi-leader replication scheme, right? And we also touched briefly upon conflict resolution. But as I said in the previous episode, that we will be covering conflict resolution in the next episode, and here we are. We'll be covering the conflict resolution here. So, um, let's let me quickly write this. So, conflict resolution. Let's first try to understand what is conflict resolution in the first place and how does that happen in a multi-leader replication scheme. Suppose I have this system here, right? And since suppose we have a multi-leader replicated system, okay? So we have a multi-leader replicated system, meaning that we'll be having multiple leaders or more than one leaders. We can assume that suppose we have leader 1 and leader 2 here, and we have a couple of more machines which we can consider as followers. Let's name them F1, F2 and F3. So now what can happen is that a client, so suppose if there is a client coming up, they can send a request to this system. Now we have two leaders. So if this request is a write request, then this write request can be directed to any one of the leaders, either be L1 or L2. So suppose at a point of time, suppose this is client 1, and suppose there is another client which is client 2, which also came up with its own write request, right? Okay. Now suppose the write request was set update the value of x to 5, and suppose for this one the write request was update the value of x to 6. Now initially suppose these machines have a initial value of x, and these two clients are saying that update the value of x. Now we have two leaders L1 and L2, so the write request can go to either of the leaders. So suppose the request from client 1 goes to L2, and the request from client 2 goes all the way to L1. So now what happens is that L2 updates the value of x to 5, right? And L1 updates the value of x to 6. Now what has happened here is that due to this multi-leader replication scheme, we have multiple leaders, and the leaders are capable of handling the write request. So every leader can handle the write request, and here what this has happened, that these leaders have handled their write request and updated the same value of x. So now what has happened is that we have a conflict. What is the conflict here? So if we see, for L1 the value of x is 6, and for L2 the value of x is 5. So we do not know that which one should be accepted by the system. So there is a kind of data inconsistency here, where one system holds a different copy of data and another system holds a different value of the data for the same copy. So this is the thing, that for same data item X, both the machines L1 and L2 have a different values. So this is kind of a data inconsistency, and this is basically conflict. And the system has to resolve the conflict and has to accept either of these values. So what a system has to do as a part of conflict resolution process is that it has to accept either x equal to 6 and let this one go, or it can accept this and let this one go. It has to decide. So in this episode we will talk about this particular conflict resolution process. What are the different processes in which a machine or a system can resolve these conflicts? Before moving into the conflict resolution scheme, let's quickly touch upon why conflict resolution or why conflict does not happen in single leader application scheme. So I'll just gonna clear this up. Perfect. Okay. So single leader replication scheme, right? So basically what happens in a single leader replication scheme is that we used to have a single leader. So suppose if I draw a system here, and let's assume that we have one machine which is a leader. Let's mark it L1, and let's have rest of the machines marked as followers. So I'll mark this as F1, F2, and F3. We can consider these as the followers. And since this is a single leader replication scheme, we will be having only one leader. So single leader replication scheme. So that's why we have a single leader here. So why this entire conflict resolution thing does not happen in a single leader replication scheme is because it has a single leader, obviously. So if we have a client, let's take a very similar use case that we took before. So suppose we had two clients, which we had previously as well, right? And what happens if they try to perform the same operation here? Suppose at the same time they try to perform a write request, right? So suppose they perform a write request, says that okay, set the value of x to 5, and this client again also sent a write request saying that hey, update the value of x to 6. Very similar to what we did in the previous section. So what can happen is that there are no multiple leaders here, or there are no more than one leader. So only single leader can take the write request, which we have read it previously in the episode 2, that in the single leader application scheme, the leader takes the write requests. And since we have only one leader, it has the capability to take the write request. So now what it can do is that it can accept the request from either of the clients. So what could have happened is that maybe this leader has a queue, right? And suppose this is a queue of this leader. Now what can happen is that this leader can accept either one of the request, not both of them simultaneously. So what it can do is that it can let's say that it says that okay, I'll accept this request first, I'll process this request first, and meanwhile this is processing, I'll put this in a queue. So what it does is that okay, let's put this request in the queue and let me process this one here. Okay, it does the processing, right? After processing, what happened is that the value of x was changed to 6, right? And after that, what happened is that okay, let me check in the queue back. Okay, I got a request in the queue, let me process it now. So now it will start processing this one, and it will change the value of x from 6 to 5. So in this way, we don't have any conflict because these requests are performed in a synchronous fashion or in a serial fashion. Like we can always order these write requests, and since we can have a specific ordering of these write requests, that is the main reason that conflict does not occur in these synchronous replication or single leader replication scheme, right? So this is the main reason, because we have a single leader, and at a time it can accept one request and it will put others in the queue. Once the request has been processed, then it will pull other requests from the queue, and in this way all these write requests will be like executed in a sequential fashion, right? And in this way we will not have a conflict, and then obviously the final value of x will be 5. So vice versa, if this request was executed first, then the final value would have been 6. That is obvious. Okay, now quickly discuss the conflict resolution scheme. So previously we discussed why the conflict happen in a multi-leader application scheme and why conflicts does not happen in a single leader application scheme. Now what we will do is that we will understand how these conflicts can be resolved in a multi-leader application scheme. So we will at a high level we will cover multiple solutions or multiple methods to resolve the conflicts. So let's start with the first method. I'll just clear that up, and yes, okay, let's cover the first method, which is last write wins. So as the name suggests, what we are saying is that the last write will have a final call. So if two requests are trying to update the same copy of the data item, then the request which updated the value of the data item at the end will have the final say. So in order to do that, we need to have something so that we can arrange these requests in a serial fashion, or we can compare the two requests and we can have a say that okay, this request is the last one and this is the first one, so that this last request, whatever update it did, it stays with the system, right? So let's understand this in a, like, drawing it some charts. Okay, cool. Again, we'll have a similar system, and this time we have a multi-leader multi-leader system. So again, as the name suggests, we will be having multiple leaders. So let's say that we have two leaders. Let's name them L1 and L2, and we have a couple of followers, right? So suppose we have three follower machines. Name them F1, F2, and F3. Okay. So this is a system. We do the same thing which we did previously. We'll have a client. Okay. We previously also we had two clients, right? So suppose we have two clients, client 1 and client 2, and both will again send write requests. Okay, both will send write request suggesting that set the value of x to 5, and it says suggest that set the value of x to 6. So this is very similar to what we did previously, but here is a catch in this resolution scheme. The catch is that every request has a ID or a timestamp associated with it, right? And that will decide the ordering of these requests. Okay, so suppose uh, at a high level, let's say that for this one, the timestamp was 103. Okay, and for this request, the timestamp was 180. Okay, let's name this request as R1. Okay, and let's name this request as R2. Now, again, what happened previously? Suppose this request was taken up by leader 1 and this request was taken up by leader 2. They both did their processing and they both set their values, right? In a very similar fashion. So they both set their values. Now what has happened is that we have a conflict in the system, that these two values does not agree with each other. We have, for the same data item, we have different values or a different value of x. Okay, now how this last write wins will resolve this conflict is by looking at the timestamp of these requests. So it will again pull out the details about the requests. So by this I mean that, let's say that it started pulling out the data, and it says that okay, for L2, the request that updated the data copy of x in L2 was R2, and it has a timestamp of 180. Now, similarly for L1, the request that updated the value of data item X was R1, and the timestamp of R1 was 103. So now it has some parameters on the basis of which it can resolve these conflicts. So this is the timestamp parameter. So we can clearly see that for L2, the timestamp of request R2 is greater than the timestamp of request R1, right? So let me this here a bit. Okay, yeah. So this is R1, right? Hence, the timestamp, the request which has a higher timestamp is the last one, and the update given by that request will stay. Hence, the machine will say that okay, I have resolved the conflict, and since the timestamp of R2 was greater, I will go with this value and I will discard this value. So we can safely say that at the end of the conflict resolution process, what will happen is that we will have a single copy, and which will be this x equal to 6 and x equal to 5 was discarded because the request which updated this this data item has a lower timestamp, and in this way it decides like how it can um, accept the values of the data items, and that's why it is called last write wins, because it orders these write requests and goes with the last one. Okay, let's quickly touch upon the second method, which is called manual conflict resolution. As the name suggests, it will take user's help to resolve the conflicts. So I'll quickly clear this up. Let's go with method 2, which is manual conflict resolution. So let's again draw the same system here. Okay, this is a multi-leader system, very similar to what we did previously. We will have two leaders. Let's name them L1 and L2. Let's have a bunch of followers. Let's say we have 3 followers. We name them F1, F2, and F3. Now what can happen is that, again, the very similar scenario which we had previously. We can have 2 clients. We can have client 1, we can have client 2. Now these clients are capable of sending the write request. So suppose again it sent a write request saying update the value of x to 5, and this client sent the write request saying update the value of x to 6. Now here what can happen is that, again, very similarly, L2 will update the value to 6 in their machine, and L1 will update the value of x to 5 in their machine. This makes sense. Now again, we have a conflict here, because there is in the system there are 2 machines which have different values for the same copy of the data, right? Okay, so L1 leader 1 has basically value of x to be 5, and leader 2 has the value of x to be 6. Now how manual conflict resolution happens? So as the name suggests, it is pretty naive. What it does is that, and you might have seen this in Google Docs as well, that if there are multiple edits, then it will sometimes ask the user that, hey, which one you want to go ahead with. It basically happens in collaboration space where user can suggest edits and all. So what can happen is that this will again open up a dialog saying that, hey, I have one conflict, right? I have a conflict, and in this conflict we have a value of x which has a value of 5, and we have again a value of x which has a value of 6. Now it will ask the user that, hey, just let me know for which copy of the value, or which copy of the data item x you want to go ahead with. Now here the user comes in the picture. So now, me being the user, what they can do is that they can give their inputs here, right? They can give their own input saying that, okay, I will select one of them and drop the others. So what it can say that, okay, either suppose the user says that, okay, I'd like to accept this one. In that case, what happen is that the system will accept this one, and it will gonna drop this one. So this is basically the manual conflict resolution scheme. So what we did here in this episode is that we touched upon multi-leader replication scheme, and why conflict resolution happens in a multi-leader replication scheme, right? We also touched briefly upon single leader replication scheme, and we also discussed why conflict does not happen in a single leader replication scheme. Now, single leader replication scheme and the multi-leader replication scheme, both these topics have been covered in our previous episodes. So I guess in episode 1 we covered the single leader replication scheme, and sorry, in episode 2 we covered single leader replication scheme, and the episode 3 we covered the multi-leader replication scheme. So do check them out if you haven't checked them before. And yeah, if you liked this video, then share it with others, like this video and subscribe to the channel. It will help a lot. I hope this distributed systems 101 series is helping you guys to ramp up on that initial distributed systems concept. I'll bring more videos or more lectures or episode under this series. And yeah, let's cover multiple concepts. And if you think that if there is any other concept which you like me to cover, do put that in the comments. It will help a lot.